Acids and Bases by James, Alex, Nick, and Marcus. So what are acids and bases? An acid is a substance that has more hydrogen ions. It gives its hydrogen ions and protons to the substance that it's reacting to, or the reactant. When an acid dissolves in a solution, it releases hydrogen ions, making a neutral substance or a weak base more acidic, or making a strong base more neutral. This is measured using a scale called pH, or potential of hydrogen. A pH value is a number from 1 to 14, with 7 as the middle or neutral point. Values below 7 indicate acidity, and above it indicate how base something is. Common properties of acid include they have a sour taste, react with metals, they can be corrosive, and they are the solutions of a compound dissolved in water. Common examples include citric acid, hydrochloric acid, sulfuric acid, and carbonic acid. Bases are substances which have more hydroxide ions than hydrogen ions. Some are soluble in water. These are called alkalis. They have a soapy, slippery feel, have a bitter taste, are corrosive, and some strong bases are caustic, which means they burn the skin. One example of an acid is lemon juice, which contains citric acid, and one example of a base is sodium bicarbonate. Indicator is a useful tool in science, as it shows how acidic or basic a substance is, as by the indicator, when with a substance, turns it to a certain color to tell us how acidic or basic it is. Universal indicator is the main indicator, as it's very accurate, such as knowing if it's acid it's red, or if it's base it's blue, as determined by the pH scale. There are also other less reliable indicators, such as lily pillies and cabbage. A neutralization reaction is an acid and base coming together to form a neutral substance. Specifically, it always forms the neutral substance of water and a salt, and rarely, just rarely, it forms carbonic acid. What's really happening though is that the atoms in the acid and base are mixing, such as hydrochloric acid and sodium hydroxide, which forms water and table salt. Neutralization reactions are important, as they provide beneficial and sometimes life-saving services to take place. Reacting with either basic substances or acidic substances, they allow imbalances to be fixed. In terms of the medical industry, they provide crucial assistance in neutralizing the gastric acids with bases that many gastric patients face. Neutralization reactions are also significant in the treatment of common bites or stings from creatures such as bees and wasps. However, one example of neutralization involves stomach acid. When the stomach makes too much gastric acid, this can cause problems. So to fix this, a base is added. This base is in the form of an antacid or anti-acid, such as magnesium hydroxide or aluminium hydroxide. These bases mix with the acid, with the negative ions mixing with the positive ions, creating the neutral substance of water. Thanks for watching.